Okay, quick review. Wilma, talk us through all the terms we had on Monday for circles. What's a radius?
It's a line segment kinetic in the center to a point on the circle.
Beautiful. How about a diameter?
It's a point from one side of the circle to the other. I mean, it's a line segment connecting 2 points of the circle, going through the center.
Perfect. What's a chord?
A line segment connecting 2 points on the circle. Not
Not
going through the
going through the center. Circumference? Yes. Good. Anything else? What else did we talk about? Did I forget something? I think that's it. Okay, got some more terminology for you today. Central angle. That's a central angle. By the way, that's a theta. Sebastian, what's a central angle?
An angle that's in the center.
That's in the center. Could you be more specific?
It's it comes from the center point and goes out.
Okay, not horrible, but can you be more specific? Number one, what's it?
The
Num-
angle,
The angle comes from the center and goes out?
yes. Well, and then it ends at the edge of the circle.
Doesn't have to.
Okay.
This could go on forever. That would still make it a central angle. Okay. So what's the difference between this and this?
What?
Is this a central angle?
Yes.
It is. No, this is.
Yes,
Why is this not?
because it's not in the central point.
Okay, what's it?
Oh, okay. So the angle doesn't start in the center point.
And what's that spot called where that angle starts?
Where that,
No, it's not there. It goes, this is
the center.
like chapter 1 stuff.
Oh, it's a point, right?
What's that point called?
Uh,
Yeah, that's funny.
Pick a letter.
oh, vertex, right?
Wow, good.
Yeah, that was good. Just went right to solving the puzzle. Correct, that is the vertex of the angle. So, okay, so let's take all that and put it together. What's a central angle?
So it's starts at the center point and it's a vertex. So a vertex of the center point.
Beautiful.
Okay.
An angle whose vertex is at the center of the circle. We are going to look at a large number of different types of angles in this chapter. The central theme behind all those angles is one simple question: where's the vertex? So you have to be able to look at an angle and determine where the vertex is. For the central angle, which is our first one, the vertex is at the center of the circle. Okay. New circle with a central angle labeled beta. If we get rid of all that other stuff, we have that thing. That thing is called an arc. Pat, what's an arc?
A curved line.
A curved line, that's a contradiction. Lines can't curve.
My bad.
Let's back up. This is what we started with. This gives us an arc. What's an arc?
Like the outside of a circle, but like within the central angle.
Not horrible, but you're overthinking it. What is that a picture of? Don't tell me it's an arc. If I showed this to a third grader, what would they tell me that's a picture of? I'm not insinuating that you're a third grader. I'm just trying to simplify things because you're trying to get too geometric with central angles and all that other fancy stuff.
They'd say it looks like it's half of a circle. Well, not necessarily half, but it's an arc of a circle.
You can't use the word arc to define the word which we're trying to define.
Is it the point?
is a part of the circle. Might be
How about a chunk? Chunk, part, portion, whatever word you want to use. That's why I said you were overcomplicating it. It's just simply a piece of the circle. And notice it's an arc, not an arch. Let's not mispronounce our words in here. Three different types of arcs we're going to talk about: minor, major, and semicircle. Remember, in this class we don't deal with angles greater than 180 degrees for the most part. So a minor arc is an arc whose arc measure is less than 180. Major arc is an arc whose arc measure is greater than 180. This is the first time we violate that rule about greater than 180. And then a semicircle is an arc whose measure is exactly 180.
How can we measure?
You'll see. Notice the different question.
Would you have to say arc and do?
No. No, when you're talking about the symbol in your notation, if you write AB with the curve over it, that's insinuating that it's arc AB. When you're talking about a minor arc, you need two letters. Where does it start? Where does it stop? When you're talking about a major arc, you need three letters. I'll clarify this a little bit in the next slide. Semicircles are also named with three letters. Common mistake that people make is they want to call this a major arc because it's from an obtuse angle. That's not the case. Remember, minor arcs are less than 180 degrees, not from an obtuse angle. Okay, so actually let's go back and use a picture here. So if I take a circle and I pick a couple points on that circle, let's go here and here and here, and we'll call this A, B, and C. The notation for a minor arc, which is two letters, means go from A to B along the circle as quickly as possible. So if I start at A and I want to go to B as quickly as possible, am I going to go clockwise or counterclockwise?
Clockwise.
Is it safe to assume you all know clockwise from counterclockwise?
Yeah.
Okay, I didn't want to insult anybody, but I know you guys don't read analog clocks anymore. Everything's digital. I had to teach my seniors this week how to address an envelope,
No way.
which I thought that was ridiculous,
No
but
way.
Are you serious?
when's the last time you mailed a letter?
Actually,
last week.
yeah,
Graduation.
I will.
Okay, sorry, maybe I was wrong. Maybe they are dumb, I don't know.
Let them fly.
Alrighty then. So the minor arc goes from A to B as quickly as possible. The major arc, ACB, says go from A to B. So go from A to B, but pass through C. Okay, so there's a distinction between the two letters and the three letters. Semicircles also need three letters because if I take a semicircle, there's a diameter, let's call this Q. If I'm talking about the semicircle AQ, do I want to go from A to Q passing through C? Or do I want to go from A to Q passing through B? That's why semicircles also need three letters. Because you have to distinguish which half of the circle you're covering.
How do we annotate that it's a semicircle?
Good point. I don't have a notation for that. You could just use the three letters and maybe throw a semicircle in front of it.
Okay.
Yeah. There's no symbol for semicircle.
Okay.
Yes, sir.
Could we like not say arc A?
Say again.
Like, could we be able to say arc A because then it'd be coming back to itself?
So you want to use this?
Yeah, can we do that?
You can. What's that the same thing as? Yeah, circle X. This is kind of, I mean, you can do it. It's just,
I was just thinking outside the circle.
it's like picking your nose in class. You know, you can do it. It's not illegal, but it's just frowned upon.
It's roundabout.
Mr. Reedy, you didn't get the pun.
I'm sorry, what,
He said he was thinking outside the circle.
Arc measure, AM. So somebody asked the question, how do we measure arcs? How do we know that it's, how big an arc is? How do we distinguish one arc from another? We use something called arc measure. The measure of an arc is the same as its corresponding central angle. Okay, so here's my arc AB. The measurement of arc AB, which will be in degrees, is the same as theta, that central angle. So notice the notation down here. The measure of arc AB is equal to the measure of the angle AMB. And we're actually going to measure two things about arcs. We're going to measure their arc measure, but we'd also like to know its arc length. How far is it if you walk from A to B along the circle? We'll do that in a little bit. Is everybody okay with this idea? Because it's going to get a little bit more complicated as we work through the chapter. When we take that vertex and move it in different locations, finding that arc measure is going to be a little bit more difficult. Okay? No? Go back? Okay, so now we have the question, well, I don't want to know how big the angle is. I want to know how far is it from A to B. How do you find an arc length? Yes, sir.
Do you have to find the angle measure first,
Okay,
then find what percent of 360 that is,
okay,
then multiply that percent times the circumference.
perfect. Now, without using percentages, we're just going to set up a simple ratio. All we're doing, don't overcomplicate this formula. All we're doing is exactly what Nick said. We're figuring out what part of the circle are we talking about. So, for instance, a semicircle is what percentage of the circle? What percentage of the circle? 50%, right. Or half. 180 over 360, 1/2 times the circumference. So take the entire circle and multiply it by the fractional part that that arc represents. Why 360, Nick?
That's a circle.
That's a circle.
The circle has 360 degrees.
Okay, good. That's better. This is not a big deal, but just so you understand the terminology, adjacent arcs are two arcs on the same circle that share one and only one point in common. Okay. Two arcs next to each other.
Are the arcs always congruent, or could
No.
they be-
No, I could have, notice how the purple guy is shorter than the red guy. As long as they just have that common endpoint, they're adjacent arcs. Yes?
Don't they share 2 points, because they would share M and
M is not part of the arc.
A? Oh.
Remember, think of circles like hula hoops, not like pies. For Pi Day.
Are they gonna be?
This room is gonna be trashed.
What kind of pie do they have? Like Baker's Square?
I'm not sure I know the whole list, but you know who does. The Google would know. Yeah. Yes, sir.
Can I bring like a gallon of milk?
That would not be a bad idea.
Say where's the gallon?
Would you be willing to share, or are you gonna do the gallon challenge?
Dude. We might need some more people to bring milk. I don't know if 1 gallon's gonna cover a whole.
It wouldn't. Yeah. Let's get back on task here, kids.
Yeah.
Focus. 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 Erica, can you name a minor arc up there, please?
FR.
Perfect. FR. Evie, can you name another one, please? Beautiful. RO. Patricia, how about another one?
FG.
FG. Beautiful. And Faith, one more, please.
GO.
GO. Good. Notice that OG and GO are the same thing. I would have gone with OG, it's the original gangster, but that's okay. You could go with GO. Nicola, how about a major arc?
F
Good start.
O G.
FOG. Fog. Very good. Maddie?
ROF.
ROF. Well done. Max, one more.
OFG.
OFG.
you already said that one.
No? He said FOG. Wilma has a question or an answer?
A question.
Certainly.
Can you use 4 letters?
No. Even if there's other points in the way, like when he said FOG, even though there's an R there, it doesn't matter. But notice that the ARC FOG is the same thing as the ARC FRG, but you still only use 3 letters. Is there another question? Yes, sir.
How do you know that R is like, if you were to list a semicircle, how do you know that it's like exactly across from G?
Excellent question. We do make certain assumptions. Like in this picture, I would assume that GR is a diameter, that it's not moved like a fraction of a degree, so it's not exactly 180. We can assume that that's a diameter. So Sam, if GR is a diameter, name a semicircle.
GFR,
And the other one is?
GOR.
Good. And how about 2 adjacent arcs? Mac?
FR and RO.
Well done. And there's a lot of them. You can keep going with that. ROOG, GOFG, GFFR. Notice that S is not part of any of those arcs, nor is it part of the circle. It's the center of the circle, but the center of the circle is not part of the circle. The circle is a hula hoop. I just colored in the center part green so that it's a little bit easier to see. Any questions on any of those? Identifying the different types of arcs. Okay, the biggest problem there that people run into is the notation, not understanding what the arcs are, but knowing how to name those arcs. Okay, now we start doing some calculations. If RSO is 57 degrees and FS is 8, find the measure of GO and find the length of RO. Make sure you understand the difference between those two questions. Question number A, that was a ridiculous statement. Question A, it's not a number, it's a letter, is asking you for an answer in terms of degrees. Question B is asking you for an answer in terms of length units, which I didn't give you, so that would just be units. And let's round B to the nearest tenth. While you're calculating, I think what I'll do is I'll create a survey on the main page of our Schoology website where you can vote on your favorite pie. That way we'll get a feel for, if you're the only person that likes some bizarre pie flavor, then you're either gonna have to switch or order your own pie. But if we find out that everybody likes cherry pie, then we can order a bunch of cherry pie or apple or some of the, stay with the basics. If you stay with the basics, they're cheaper also. Zach has a question.
You're thinking that like each pie could bring their own like milk and cups and everything.
Each cluster,
Oh,
if you will. Okay, that's understandable. That way, if you don't want milk, you don't have to bring it. And of course, if one pie group brings in a whole gallon, they would probably be willing to share. But I wouldn't assume that there would be anyone to share with. So, good strategy. Just as a quick survey, how many people are interested in having pie on that day? Raise your hand.
Kidding me?
Okay, thank you.
But what day is this?
Oh,
gonna
whoops,
be?
did the wrong
A
next
week
day.
from Friday.
Grace does too, we talked about that before.
Okay, way to throw Grace in the mix.
Yeah.
Maybe we can make
And Grace wants the most expensive pie
Oh,
out
yeah,
there.
she wants
And she
Oreo.
said she wants her own pie, so if you could order that for her.
She wants Oreo.
Oreo.
She's calling me.
Emma, how big is our GO? Why?
Oh, it's GR.
Go ahead.
It's a linear pair.
What angle are we talking about? Name the angle.
RSO is 57, so because it's a linear pair with GSO, it would have.
There you go, GSO. So gopher, snake, octopus is, how much did you say? $1.23. Okay, and therefore,
Then the arc would be
the arc would be the same thing. Minor or major arc?
final.
Minor, because it's less than 180 degrees. Okay, now the hard one. How long? Jock, question or answer?
Question.
Certainly.
On a test or quiz, will you tell us if GSR is a diameter or will?
More likely, I will tell you is if it's not a diameter.
Okay.
In the picture like this, you can assume that GR is a diameter. All right, how long is RO? Rich?
Okay, so you have to start off by finding.
Wait, hold on, before we proceed, what'd you get for an answer?
Oh, RO, I got 7.96.
Anybody else?
Rounded.
Okay, they like that, so we'll go with it, go ahead.
Okay, so, well, actually, you don't need to figure that out. So you just need to find the circumference. So you need to set up circumference equation. So it'd be C equals 2 pi r. And then we have the radius since Fs is a radius. So then you set that up, you solve, there you go. And then you have the angle measure of 57. So then you put 57 over 360 and you plug it into the angle length or arc length equation and then times the circumference, which is 65. And then you solve it. And, then round
And you
it
got
up.
7.96 units. Now, you could eliminate this step and go right to arc length is equal to AM over 360 times 2 pi r and plug and chug into one formula. It doesn't matter. Separate formulas or one formula, you get the same results. Okay? Sam?
Can't we just multiply 16 times pi, then stow it, or store it, and then put it?
Yeah, that's fine, but you still have to plug, you still need to show me some work.
Oh.
Start with a blank formula, plug in what you know, solve for what you don't know. Thought you had a question.
No, just stretching.
Okay. Find the length of the arc DA. That 12, by the way, represents BC, not the diameter,
Oh.
I think. No, sorry, that's a diameter, it's in this middle. What you'll find is a lot of you are going to get so focused on using the radius that you're going to continue to do silly things like you're going to take the diameter, which is 12, divide it in half to get the radius, which is 6, and then put it back into the formula, which ends up doubling it again, so you get back to 12. There's nothing wrong with that. It's just a lot of work, so I went right to d pi. What's AM? What's the arc measure? Yes, Nick?
Oh. The arc measure is 152.
What do you got for me?
15.92.
Somebody confirm?
Yes.
Units, centimeters, there. Remember, arc length is measured in linear units. Arc measure is measured in degrees. Measured in degrees. Wow, that's a pitiful 5.
So it's like a backwards 7.
Don't start with me. Jack, you want to try this? Okay, so you got to read the word. Wait, I forget which one. Don't look. You got to read the color, not the word. Okay, you ready?
The color, not the word.
Read the color, not the word.
You have to say what color the word is.
Yeah.
Yeah.
Say what color the word is.
colors.
The word will be a color, you have to say what color
So
that word is.
say it's yellow but blue. Am I saying?
Oh my
That
god.
was so
Oh my God.
intense.
Say what color the font is.
If it's
not
spelled
what
Yeah,
color.
what color?
Okay.
Fine, here we go.
Green, red, blue, yellow,
Come on,
Blue.
come on.
black,
Come on, come
Red,
on, faster,
blue,
faster, faster.
green, black, red, yellow, green, red, black, red, blue, green.
Too slow.
I think the purple, the
But
first.
wait, I think you got it wrong at the
Yeah.
end.
Did he
You
screw it up
said
at the
red,
end?
blue, green.
Yeah.
I was like, wait.
Once he was going so slow, I just bailed on it. Tyler, you ready? Okay,
Ooh.
I guess. If I have to. Go.
Green, red, blue, yellow, blue, black, red, blue, green, black, red, yellow, green, blue, black, blue, red, green.
Nice.
He's got.
Well done. Well
I
done.
got beat. Bad.
That's
I
all right.
roasted.
It's good for you. Competition builds
Colors
character. It's in your chest.
spelled correctly.
Day 2.
Left, right, conflict.
Again, getting all the terminology under control. Notice that we've only really done three calculations up to this point. Circumference, arc measure, and arc length. Everything else is just terminology. We need to make sure we understand the terms before we move on to bigger and better things. Okay?